Welcome to Home Networking 101, your comprehensive guide to mastering your home network. This is part 2, where we're going to explore everything that you need to know about internet connections. From cable to fiber to 5G and satellite, we're going to cover all of the pros and cons of each option. And of course, this wouldn't be a complete tutorial series without showing you some invaluable troubleshooting tips to ensure that you're maximizing whichever internet service you may be using. All right, let's dig in and get started. The many types of internet connections available can be confusing. In this video, we're going to break down the different options to make it as easy as possible to make the right choices. But if you're looking for some expert assistance, be sure to check out Rogue Support. Rogue Support provides expert, independent computer networking assistance regardless of your internet connection or equipment. Our experts are standing by to assist you with your networking issues. From setup and configuration to optimizing your internet connection, we've got you covered. So say goodbye to the frustration of trying to navigate internet problems alone. Visit us on the web at rogue.support or click the link in the description below to connect with one of our friendly rogues. With Rogue Support, you're just a few clicks away from conquering your network challenges and enjoying a secure and reliable home network. The best place to start when figuring out which internet options are available to you is to do some online research. There are a number of websites such as allconnect.com, broadbandnow.com, or highspeedinternet.com, where you can enter your address or zip code and receive a complete list of the internet service providers or ISPs in your area. Now, this is a great starting point, but make sure you always do your own research as well, because some of these sites do tend to be biased towards certain vendors. When looking at these various options, there are a few important things to consider. Price, of course, can vary greatly depending on the type of connection, but you also want to check what internet speeds or bandwidth is available. Internet connection speeds, also known as bandwidth, is a measure of how much data can be transferred to and from your home simultaneously. Internet speeds are measured in megabits per second, or Mbps. Megabits is denoted with a small b in Mbps and should not be confused with megabytes, which is MB with a capital B. So then what's the difference? Well, megabits per second is a measure of internet speed, a measure of bandwidth, whereas megabytes is a measure of data size. So imagine megabits as the number of cars that can simultaneously travel down a highway. Lower bandwidth or lower speeds means fewer cars can get through, just like a one-lane road. Higher speeds means that more cars can get through, like an interstate highway. Megabytes, on the other hand, is more like how many cars can be parked in a parking lot. They're not moving, it's just a measurement of size. So for instance, you may have a digital photo that's 20 megabytes. That's how much data or space that photo takes up on your hard drive. Internet connections are measured in megabits, and most often you're going to see speeds up to 100 megabits or up to 1200 megabits per second. Now, when you see this advertised, the ISPs are usually talking about download speeds, meaning how fast can data be delivered from the internet to your home internet connection. Another thing to consider, though, is upload speeds. So like my internet connection here at home is 600 megabits down or download and 40 megabits up or upload. The reason the download speed is usually a lot higher than the upload speed is because the majority of data flows in that direction. When you're streaming music or movies, you're just surfing the internet, or you're downloading a file, you're mostly using your internet connection's download speed. So by comparison, the upload speed doesn't have to be as large, since you're making much smaller requests out to the internet and then receiving a large amount of data back from the internet. That being said, sometimes you will see symmetrical internet connections, which basically just means that the download and upload speeds are the same. So let's talk about the various types of internet connections available today, and we're going to start with DSL. DSL stands for Digital Subscriber Line, and it's internet delivered through your existing telephone lines. DSL was hugely popular 10 to 15 years ago, before ISPs had laid down the more current cable and fiber infrastructures that we see most commonly today. There are a couple different types of DSL, but most often ISPs provide ADSL. And the DSL speeds are somewhere between 1 to 20 megabits download and around 1 megabit per second upload. The speeds that you can achieve actually depends on how close your home is to the telephone exchange that's providing that connection. One of the most common types of internet connections available today is cable internet. This is where the ISP delivers your internet connection over coaxial cable wires that most homes already have to provide their cable television service. These cables have higher capacity for faster internet speeds than DSL. Cable internet is most often in like the 60 to 400 megabit range, but it can go as high as 1 gigabit in some places, though it does start to get a lot pricier when you hit those higher speeds. Another option that's becoming more popular is fiber internet. Fiber internet uses fiber optic cables to transmit data, and it's known for being incredibly fast and reliable. Inside a fiber optic cable is super thin strands of glass that transmit data using pulses of light. It's actually quite an amazing technology. Fiber internet speeds are much faster than what's available with cable, and they range from like 100 megabits per second up to multiple gigabits per second. And the upload and download speeds are usually symmetrical, meaning they're the same upload and download. If fiber's available in your area, this would be my recommendation. Usually, however, it's only available in more densely populated areas, but you can usually get cable internet almost anywhere these days. A new home internet option that we're seeing more of is 5G wireless. So here in the US, many of the big cellular carriers are repurposing some of their cellular bandwidth for home internet. These connections are actually pretty cost effective, but they're only as good as the 5G wireless signal that you can get in your home. The speeds you get are also very dependent on where you place the modem that the ISP gives you. You're usually going to want to have it in a window where it has a clear view of the outside world in order to get the best signal. Just like how your cell phone won't receive as good a signal if you're down in the basement surrounded by concrete. If you're in an area that has good 5G wireless coverage, you can sometimes get internet speeds of multi-hundreds of megabits per second, and the costs are usually around $50 a month, or cheaper if you're bundling your 5G home internet with your cell phone. Now just keep in mind that wireless internet is never going to be as stable and reliable as wired internet. Along with 5G home internet, another option that's especially popular with folks who travel around in RVs is LTE, or 4G internet. Very similar concept in that LTE internet uses the cellular network to deliver internet, but the speeds aren't quite as fast as they are with 5G. Let's talk a little bit about satellite internet service. Legacy satellite internet service is absolutely horrible, right? But sometimes it's the only option available if you're in a really super remote area. Legacy satellite internet, such as HughesNet, uses what's called high Earth orbit satellites to beam internet service down to a satellite dish on your home. The high Earth orbit satellites are around 22,000 miles or 35,000 kilometers above the Earth, and they are very susceptible to weather conditions that can degrade the signal significantly. High Earth orbit satellites can usually deliver speeds ranging from 12 to 100 megabits download and 3 to 20 megabits upload, but they're really not great for anything other than like light web surfing and reading emails. The newest satellite internet services, such as Starlink, use low Earth orbit satellites. This service is basically a large constellation of satellites that are much closer to the Earth. They're at about 340 miles or 550 kilometers. Now, because these satellites are closer to the Earth and they use newer technology, services like Starlink can deliver higher bandwidth and more reliable internet connections that can actually be used very successfully for video calls and streaming music and movies and gaming. Starlink speeds range between 50 to 300 megabits download and 20 to 40 megabits upload. Finally, let's explore wireless ISPs, or WISPs. These ISPs are often independently owned and operated companies that cater to underserved areas where traditional ISPs are scarce. However, WISPs are not limited to remote regions. Many cities now offer WISP options as well. So how do WISPs work? Well, they utilize a point-to-multipoint antenna to transmit internet signals from central locations out to their customers who have a receiving antenna in their home. Interestingly, in certain areas with limited DSL or satellite options, WISPs can provide faster internet service than some of the larger ISPs. It's actually a promising alternative that is worth considering. When you sign up for internet service, the ISP provides you with a modem, and that modem acts as a bridge between your home network and the ISP that's providing the connection, right? It connects your home network to the internet by terminating the incoming connection from the ISP on one side and then providing an Ethernet port for you to connect to your home network on the other side. Typically, you're going to plug the connection from the modem into the WAN port of your router. Sometimes the ISP provides a combo device that combines a modem, a router, a wireless access point, and a switch all into one unit. Now, while this can be convenient for basic internet needs or networks that really only have like wireless devices, the equipment that they provide you is usually not the highest quality, and you have limited options for extending or optimizing your network. Also, leasing this equipment from the ISP can usually be like 10 or 20 bucks a month. They charge you like a wireless fee or something. And that can really add up over time, right? But in some situations, that type of device is perfect. My mother-in-law, for example, has a single-story home with one of those combo devices, and it's a great fit. For a secure and reliable home network, it's generally recommended to keep the ISP's modem as simple as possible and use it only as a bridge between the ISP and your own network equipment. Most ISPs allow you to put their modem into bridge mode, which also may be referred to as modem-only mode, pass-through mode, or transparent mode. By enabling bridge mode, you disable the routing capabilities of the ISP's modem. Instead of functioning as a router that directs network traffic, the modem becomes a pass-through device. This allows you to assign your WAN IP address to your own router rather than having it live on the modem. But okay, now we're getting a little bit ahead of ourselves. So let's briefly talk about what a WAN IP address is, and then we're going to dig deeper into IP addressing in a future video. Inside your network, you have devices, right? Smartphones, computers and laptops, smart TVs, gaming consoles. All of these little smart devices live on your network, and they are given a private IP address on the LAN, or local area network. These private IP addresses are not accessible from the public internet. However, your router has a WAN IP address, also known as a wide area network IP address, that is publicly accessible. When you request information like surfing to a web page or streaming a video on Netflix, a server sends that data back to your WAN IP address. It's similar to like ordering a package from Amazon, right? You buy something and you provide your public home address, and the package is delivered to your house. It's not delivered inside your house, it's just delivered to your front doorstep. So how can you see what your own WAN IP address is? The easiest way to do that is go to a website such as whatismyip.com. You'll see your WAN IP listed next to my public IPv4 is. The WAN IP also reveals your general location as well as the ISP that you're using. There are two types of WAN IP addresses, static and dynamic. Most home users have dynamic IP addresses, meaning that their IP addresses are dynamically assigned to the modem or router and have a tendency to change over time, especially during ISP network maintenance or like a severe power outage. While this typically isn't a problem for most people, in fact, most people don't even know that their IP address has changed, if you require a fixed IP address, you can request what's known as a static IP address from your ISP. Usually comes with an additional monthly charge, but the advantage to having a static IP address is that it doesn't change. So if you have services that you're running out of your home network, such as a website, it's going to always be accessible on that same WAN IP address, which reduces the chance of an outage. If you do happen to have a dynamic IP address, but you need to always be able to connect into your home network from the outside world, it is possible to set up what's known as a dynamic DNS name, or DDNS, but that is beyond the scope of this video. We're going to be discussing DNS and dynamic DNS names in a future video. Okay, so earlier in this video, we talked about internet connections that are measured in megabits per second, and more specifically, that your internet connection has both an upload and a download speed. But if your ISP is providing you with a cable connection that's supposed to be like 300 megabits download and 40 megabits upload, how can you test that? So in order to test that, you can run a speed test. One of the most popular speed tests available online is speedtest.net. When you open speedtest.net and you click Go, this website is going to measure your upload and download speeds and then report that information back to you. This is a great way to test whether your home network is actually getting the internet speeds that you're paying for. Speedtest.net also shows you your internet latency, which refers to the lag experienced when sending data from one point to another. So imagine that you're playing catch with your son, right? The time it takes for the ball to travel from your hand to your son's hand represents the latency. Now imagine playing catch in two different scenarios. You're playing catch in a really small room, and you're playing catch in a really large field, right? In a small room, the ball travels very quickly back and forth from one person to another, but in a large field, it takes a lot longer for the ball to travel the longer distances. You want latency to be as low as possible, but different factors such as how many devices your data is flowing through, network congestion, or the distance between sender and receiver can all increase latency. When you have high latency, this can result in sluggishness when making video calls, streaming movies, or gaming. Let's now talk about some basic troubleshooting steps that you can do if your internet connection is slow or not working properly. One of the easiest tools that you can use to just check to make sure your devices can see the internet is to run the ping command. In Windows, you can do this by opening up a command prompt. So click on the Start button, and then you type in either Command or CMD. On a Mac, you want to open up Terminal to do the same. Now, once you have that open, you'll have a text-based prompt, and you can start typing in commands. So type in ping space 1.1.1.1 and then press enter. In this case, ping is the command that we're running, and 1.1.1.1 is the destination that we're trying to get to. Now, I use 1.1.1.1 in this example just because it's really easy to remember. That is a WAN IP address that belongs to an organization called Cloudflare, and it can be used for DNS resolution, which is the way that we translate names to numbers on the internet. More on that in just a bit. Now, for our purposes, just know that 1.1.1.1 is a server out there on the internet somewhere. If you ping 1.1.1.1 and you get a reply, then you know that your computer can see the internet. If you don't get a reply and instead you see something like request timed out, then whichever device you're using to ping is having trouble seeing the internet. Now, a second ago, we talked about DNS resolution. DNS stands for Domain Name System, and basically DNS is used to translate friendly names that humans can remember into IP addresses. So, for example, if you wanted to visit Rogue Support to get some assistance with your home network, you simply type rogue.support in your web browser and you're brought to the Rogue Support webpage. But behind the scenes, Rogue Support, just like any other website, has a publicly accessible IP address. The IP address is how your computer talks to that server, but there's just no way that humans would be able to remember the IP addresses of every website that they want to visit. So we use friendly names instead, like google.com or amazon.com or rogue.support. DNS is the service that converts those human-friendly names into computer-friendly IP addresses. So now back to that ping command. If you're trying to get to a website and it's not working, it's entirely possible that your internet is actually fine, but your computer is having trouble with DNS. It can't translate that human-friendly name into an IP address. You can test this out by first pinging the website that you're trying to get to, such as ping rogue.support. And here we can see that we're getting a reply from the rogue support IP address. If we also then ping that IP address directly, we should get the same replies. Now, if you can ping the website by IP address, but you cannot ping it by the friendly name, then you have some sort of issue with DNS resolution. If you can't ping the website by name, but you can ping other websites by name, then it's possible that there's some sort of issue with that one particular website. Another really common issue is slow internet speeds. If you're on your computer and you're running some speed tests, and those speed tests are showing you like very slow speeds compared to what you're supposed to be getting from the ISP, this is an indication that something isn't working correctly on your network. To help troubleshoot what could be wrong, you need to start taking devices away in between your computer and the internet. For example, let's say I'm on my laptop and I'm running speed tests that are very slow. Well, maybe it's an issue with the wireless access point that I'm connected to. So in that case, I would want to plug my laptop directly into a network switch and then try to run those speed tests again. If the internet speed is fine when directly connecting to the network switch, then I know the issue has something to do with the wireless connection. But if the speeds are still slow, then the wireless is actually probably fine and I'm going to want to try something else. In this case, the next logical step would be to try plugging the laptop directly into the router or modem so that I can get as close to the internet as possible and keep running those speed tests. Now, if you get all the way to the router or modem and your speed tests are still slow, then you would likely want to place a call to your ISP to report the problem. Another very common problem is wireless signal issues, but we're going to cover that in a future video on Wi-Fi fundamentals. Make sure you like this video if you learned something new and subscribe to Crosstalk Solutions so you don't miss out on the rest of this tutorial series. And if you'd like to keep this party going, I have hand-selected 2 videos on the right here for you to watch next. The top video is the previous video in this tutorial series, and the bottom video is a video where I accidentally broke my own network and I had to troubleshoot the problem until I figured it out. I definitely could have used help from rogue support on that one.